Welcome back. In this video, we are going to talk about b, the constant b. The constant b, I want you to notice where it's located because that lets us identify, which constant is. It's multiplied times the x. It's on the inside. It's attached to x. Remember, x is bad, so whenever things are on the inside, they're always going to behave the opposite of how we think. Now, a couple things we know, multiplying makes us think, okay, well, if it's multiplication, it's going to be a shrink or a stretch or possibly a flip. And then inside, I know this is going to be horizontal. All right, so b, the absolute value of b, represents any horizontal stretching or shrinking. So stretching out or shrinking in. B also affects the period. Now, if the absolute value of B is a number that is greater than 1, and so normally you think, hey, you multiply by a number bigger than 1, it should get bigger. Well, remember, it does the opposite. This is going to shrink horizontally by a factor of 1 over b. We're doing the opposite. So the opposite of multiply is divide. And if it is fractional between 0 and 1, that's going to cause it to stretch horizontally, again, by a factor of 1 over that absolute value of b, because this is a fraction, and divide by the fraction, copy, change, flip, you multiply by the reciprocal. Lastly, if b is a negative value, if we have a negative value here, we are going to reflect horizontally across the y-axis. So that means we're going across that vertical axis horizontally. All right, now one thing we know, we said this affects the period. The period for any sine or cosine graph is always going to be 2 pi divided by that value. And we say the absolute value because the period is a positive number. If we were dealing with tangent, the period of tangent is pi. There's little dots all over here from my wrist. The period of tangent is always going to be pi. So in this case, it would be pi over b. You may see a tangent on your lab, so just keep that in mind. So now we're going to do an example where we sketch the graph of two functions. We have an a and a b here. So for a, we have y equals the cosine of the quantity. My argument is 4 times x. So you'll notice I've drawn my standard cosine graph, and I have my key points. My key points for cosine, I have 5 key points. We always want to start with those key points. I have 0, 1, pi over 2, 0, pi negative 1, 3 pi over 2, 0, and 2 pi positive 1. So what does this times 4 in the argument, multiplying by the x, do? This is going to cause the graph to shrink horizontally by a factor of 1/4. It's going to become 1/4 as wide. What's that going to do to my ordered pairs? I'm going to take my x values and divide them by 4. So I have x over 4, comma, y. Since this is a positive value that we're multiplying by, there's no flipping. There's no horizontal flip, but it's shrinking by 4. And so you think, okay, it's on the inside. It's going to do the opposite of what we think. So I think it's going to normally, I'd look at that and go, oh, it's going to stretch by 4, but it's doing the opposite. It's shrinking horizontally. Each of my 5x values, I'm going to divide them by 4 to get my new key points. So 0 divided by 4 is still 0. Pi over 2 divided by 4 becomes pi over 8. Pi divided by 4 becomes pi over 4. 3 pi over 2 divided by 4 is 3 pi over 8. 3 pi over 8, 0. And 2 pi divided by 4 is pi over 2. So what has happened is instead of going from 0 to 2 pi, we're going from 0 to pi over 2. So this cosine graph shrinks in here like this. It is 1/4 as wide as it used to be. The period of this, we can see, is pi over 2. And remember, we said we're going to calculate the period by saying the absolute value of 2 pi over my b. Here my b value is 4. So my period is pi over 2. All right, so we've got one more example in this video. Here we have y equals the sine of x divided by 3. Now keep in mind that's the same as y equals the sine of 1/3 x. So I've graphed my standard sine function between 0 to 2 pi, one period of my parent sine function. What is this 1/3 going to do? Well, it's multiplied and it's on the inside. So when it's multiplied, we know it's a shrink or stretch. When we know it's on the inside, it's horizontal. It's going to do the opposite of what we think. So this is actually going to stretch horizontally by a factor of 1 over 1/3. 1 over 1/3 is 3, by a factor of 3. That's going to take all of my x values and multiply them by 3. Again, we have x divided by 1/3 y. And dividing by 1/3, that's the same as multiplying it by 3. So all of my x's are going to become 3 times as large. Is there a horizontal reflection here? Are we going to reflect over that y-axis? And the answer is no, there's no reflection because there's no negative. So let's look at our key points. Our sine graph, the key points for sine. We start with 0, 0. I've got pi over 2, 1. Pi 0, 3 pi over 2, -1, and 2 pi 0. So if I take each of these 5 y values and I multiply them by 3, what do they become? Well, 0 times 3 is still 0. Pi over 2 times 3 is 3 pi over 2. So I've got 3 pi over 2, 1. Then I have 3 pi, 0. I've got 9 pi over 2, -1, and then 6 pi, 0. So I've got a point at 0, 0. I'm going to go to 1.5 pi, which is about here at 1.5 pi. I'm going to go up 1. At 3 pi, I'm at 0. 4.5 pi, I am down 1. And 6 pi, we are at 0. So you see, this has stretched out and become 3 times as long. In fact, what is the new period? Remember, the period is 2 pi divided by that b value. So 2 pi divided by 1/3 gives me 6 pi. 6 pi is my new period. All right, so one more value to consider. We have looked at A, D, and B. Now we're going to look at C and how C can change, especially in conjunction with having a B value in there.